Good day, students. Welcome to Term 1, Week 4 of JSS 1 Mathematics. Today we begin our study of factors and multiples, one of the most important topics in number theory, and a topic that appears on virtually every BECE and WAEC examination paper. By the end of this lesson, you will be able to define a factor and find all the factors of any whole number, identify prime numbers and composite numbers, distinguish between prime and composite numbers correctly, and explain why one is neither prime nor composite. Let us begin. A factor is a whole number that divides exactly into another whole number with no remainder. We also say, a factor divides its number evenly, or a factor is a divisor of the number. For example, does 3 divide exactly into 12? 12 divided by 3 equals 4, yes, exactly, no remainder. So 3 is a factor of 12. Does 5 divide exactly into 12? 12 divided by 5 equals 2 remainder 2, no, there is a remainder. So 5 is not a factor of 12. Every whole number greater than 0 has at least 2 factors, one on itself. 1 divides into every number exactly. Every number divides into itself exactly. Now, based on how many factors a number has, we classify whole numbers greater than 1 into 2 types, prime numbers and composite numbers. A prime number has exactly 2 factors, one on the number itself. Examples: 2, 3, 5, 7, 11, 13. The number 2 is the smallest prime number and the only even prime number. A composite number has more than 2 factors, it has at least 3 factors. Examples: 4, 6, 8, 9, 10, 12. Any number that is not prime and not 1 is composite. The number 1 has exactly 1 factor, only itself. Therefore, 1 is neither prime nor composite. This is a fact examiners test specifically. Let us learn the systematic method for finding all factors of a number. To find all factors of any number, divide it by every whole number starting from 1, going up, and write down each number that divides exactly with no remainder. Example: find all factors of 24. Divide 24 by 1, answer is 24, no remainder. So 1 and 24 are both factors. Divide 24 by 2, answer is 12, no remainder. So 2 and 12 are both factors. Divide 24 by 3, answer is 8, no remainder. So 3 and 8 are both factors. Divide 24 by 4, answer is 6, no remainder. So 4 and 6 are both factors. Divide 24 by 5, answer is 4 remainder 4, not exact. 5 is not a factor. Divide 24 by 6, we already have 6 from the pair above. Stop when the divisor reaches or exceeds the square root of the number. All factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. That is 8 factors. Now let us list the prime numbers from 1 to 50, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. There are 15 prime numbers between 1 and 50. These are worth memorizing for examinations. A practical Nigerian example: a teacher in Ibadan has 30 students and wants to divide them into equal groups for a group activity. She can only make groups whose size is a factor of 30. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. So she can make groups of 2, 3, 5, 6, 10, or 15 students, all without anyone left out. Here are 3 examination-style questions. Question 1. Find all the factors of 36. Start from 1. 1 times 36 equals 36, factors, 1 and 36. 2 times 18 equals 36, factors, 2 and 18. 3 times 12 equals 36, factors, 3 and 12. 4 times 9 equals 36, factors, 4 and 9. 536 divided by 5 gives remainder, not a factor. 6 times 6 equals 36, factor, 6. Stop here, we have reached the square root of 36. All factors of 36, 1, 2, 3, 4, 6, 9, 12, 18, 36. Count, 9 factors. Since 36 has more than 2 factors, it is a composite number. Question 2, is 97 prime or composite? Test divisibility by prime numbers up to the square root of 97. Square root of 97 is approximately 9.8. Test primes, 2, 3, 5, 7. 97 divided by 2, remainder 1, not divisible. 97 divided by 3, 9 times 10 is 90, plus 7. Sum of digits, 9 plus 7 equals 16, not divisible by 3. 97 divided by 5, does not end in 0 or 5, not divisible. 97 divided by 7, 7 times 13 equals 91, 97 minus 91 equals 6, remainder 6, not divisible. Since 97 is not divisible by any prime up to its square root, 97 is a prime number. Question 3, true or false, the number 1 is a prime number. False. The number 1 has only one factor, itself. A prime number must have exactly 2 factors. Therefore 1 is neither prime nor composite. 3 critical mistakes. Mistake 1, saying 1 is prime, it is not. Prime requires exactly 2 distinct factors. 1 has only 1. This error costs marks in every examination. Mistake 2, saying 2 is composite because it is even, 2 is the only even prime, all other even numbers are composite. Mistake 3, missing factor pairs when listing factors. Students often list only small factors and forget the large partners. For 36, students miss 18 and 36 if they do not list pairs systematically. Excellent. Let us summarize. A factor divides exactly into a number with no remainder. To find all factors, divide systematically starting from 1, recording pairs until you reach the square root. A prime number has exactly 2 factors, 1 and itself. The prime numbers to 50 include 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. A composite number has more than 2 factors. 1 is neither prime nor composite. For homework, list all factors of 48, 60, and 100. Then circle all prime numbers in the list 1 to 30. Attempt a quiz on your LMS. Keep studying hard. Visit Lightech Academy at academy.lightech.com.ng for more NERDC-approved lessons from JSS 1 to SS3, all subjects, all terms. Powered by Lightech Solutions Limited. Until next time.